Hi everyone, I am Balaji Chipada and welcome back to my YouTube channel. In continuation of our series Probability and Statistics, in this video, we will take an example and understand how to calculate PDF and how to calculate CDF, and we will also look at how CDF will be in case of a normal or Gaussian distribution. In the previous video, we have learned about these distributions, right? So if you forgot about that, please do watch that video and then watch this video for a better understanding. So without any delay, let's get started. So let's say I have a task in which I have three unbiased coins. A coin can have either head or tail, and then all of these coins are tossed. Now the task is, what is the probability of getting 0 heads, 2 heads, 1 head, and 3 heads? So let's tackle this problem using intuition first, and then let's calculate all the outputs. Hopefully that is clear. So we will consider this as a random variable, and then what we have to do, probability of random variable x is having 0 heads, and probability of random variable x having 1 head, probability of random variable x having 2 heads, and probability of random variable x having 3 heads. We have seen this notation in the previous videos as well, right? So what we have three coins, and each coins have either head or a tail. So if I toss all of these three coins once, so I might get head, head, head. Maybe all of this I will get heads, or maybe head, head, tail. I can get like this, or maybe head, tail, head. I can get this combination, or maybe head, tail, tail. I can get this, and maybe head, tail, head, and tail, head, and tail, 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 head, tail, tail, tail. So all of these are the possible combinations when I toss three coins in which they are having heads and tails, right? So what are the total number of occurrences that I can have? 8 possible combinations. Now what is the first question? I want to calculate probability of x having 0 heads. So out of all of these, I have only one possible combination in which there are no heads. So the answer for this is 1 by 8. So how did we calculate? So out of all the possible combinations, there is only one combination in which I have 0 heads. So I can get 1 by 8th chance. So when I toss three unbiased coins, so what is the chance of me not getting any of the heads is 1 by 8. Clear? And likewise, we'll check out for the probability of x equal to 1. So here I will not take this one because it is having 3 heads. I have to calculate having only one head. So what is this? So this is a record in which it is having only one head, and this is a record in which it is having only one head, and this is also a record in which it is having only one head. So the output would be, out of all the occurrences, which is 8, I have 3 occurrences in which I have at least one head. Hopefully that is clear. And now let's look at this one. So which is, I have 2 heads. So this is 1 and this is 2, and this is 3. So this is 3 by 8, and then probability of having all the 3 heads, only one probability, which is 1 by 8. So what are the values? 1 by 8, which is 0.125. So this is 0.125, and then we have 3 by 8, which is 0.375. This is 0.375, and this is also 0.375, and then this is 0.125. So let me summarize all of this in a single table, and let's understand further. So probability of x having 0 heads, and probability of x having 1 head, probability of x having 2 heads, and probability of x having 3 heads. So the output that we were able to calculate is 0.125, and then 0.375, and then 0.375, and then 0.125. Clear? So this is what we have calculated. So this is called probability mass function. So it is like calculating an occurrence given all the occurrences that we have. We have a standard mathematical formula as well. If you want, you can go through that, but I want you to understand the intuition on how you can calculate the probabilities given a given task. Now let's talk about cumulative density function. So this is called as cumulative density function. So what this is, what is the meaning of cumulative? Cumulative means stacking up. So when I talk about cumulative density function of x equal to 0, I have to look at all the probability values until x equal to 0. So if you look at before the events, before x equal to 0, there are no events, right? And the probability value is always 0 because there is nothing. And all the probabilities after having 3 heads, it will be 0, right? So cumulative density function, what it says is, for a random discrete random variable x, and we are calculating CDF at x equal to 0, we have to sum up all the values that comes until x. So in this scenario, we don't have any prior values, so you have 0.125. But when I talk about x equal to 1, and we are calculating cumulative density function, we have point x equal to 0 plus point x equal to 1. So you are adding up all the points up until the current point. So that is what we call it as a cumulative. So this would be 0.125 plus 0.375. So what is this? 0.125 plus 0.375. So which is 0.5. So this value is called 0.5. And x equal to 2, then I would have to calculate p of x equal to 0 plus p of x equal to 1 plus p of x equal to 2. It would be 0.5 plus 0.375, which is 0.875. And then x equal to 3, then what I would do? I would do p of x equal to 0 plus p of x equal to 1 plus p of x equal to 2 plus p of x equal to 3. It would be 1. So if you look at all the values, we have 0.5, sorry, not 0.5, first one is 0.125. Let me erase this. So initially we have 0.125, 0.5, 0.875 and 1.0. So if you look at this, all of these values lying between 0 to 1. Clear? So this distribution is called cumulative density function. Clear? And let's understand the intuition of it. So this is for x equal to 0, and this is for x equal to 1, x equal to 2 and x equal to 3. So what is the meaning? So what is the probability of having less than 2 heads, less than or equal to 2 heads when you toss 3 coins? So that is this cumulative probability, which is 0.825. But when we talk about PDF in the first part, it is basically what is the probability of having exactly 2 heads. It is not 2.1 heads, 3 heads, 4 heads. It is exactly 2 heads. So the probability of having exactly 2 heads when you toss 3 coins, that is 0.375. And what CDF says is the probability of having less than or equal to 2 heads when you toss 3 unbiased coins is 0.875. Clear? So that is the intuition of CDF. Now that we have learned all of these things regarding PDF and CDF, let's understand how CDF plot varies in terms of a Gaussian distribution. So remember this plot, right? We have seen in the previous video, we have 4 different plots, which is Gaussian distribution plots. And out of these, we have 3 plots in which mean is 0. That means they are centered at 0 and both are symmetric on the left side and right side. And if mean is -2, it is also symmetric, but the mean is not centered to 0. And based upon the variance values, the width of the plot will get varies. Hopefully that is clear. Now we will understand the CDF for the same plots here. In the previous video, I haven't talked about it because I want to explain what CDF is. So if you look at this one, so this is the CDF plot for all the 4 different plots that we have. And if you look at it, let's take some random point here, and which would be, let's say, 0.5. Let's assume like this. So let's take this value, which is 0.5. So let me delete this. So let me take 0.5 value. So this is the point of contact, right? So what is the meaning of this CDF function is, if my random variable x is 0.5, let's assume like that. So what is the probability of x having less than or equal to 0.5? That is what we have seen, right? What is the probability of having less than or equal to 2 heads when you toss 3 coins? So likewise, what is the probability of my random variable x less than or equal to 0.5. So that is basically this value, which is 0.8. And if you look at another one for this distribution, this is 0.7, something like that. So based upon that curve, the value, probability values will get changed, right? And if you look at it or observe carefully, we have values from 0 to 1. So this is called CDF. And when the mean is 0, it is centered at this point. What that means is, when your random variable x less than or equal to 0 is 0.5. Clear? So when I say I have a normal distribution or a Gaussian distribution in which my mean is 0 and I could have any amount of variance, let's say 3, I can conclude that if probability of my x, which is my random variable, less than or equal to 0 is exactly equal to 0.5. So these are all the properties of a normal distribution. So this is very important to learn actually. So if you know the distribution of a data set, and if you know the properties that it already applies to, without looking at the data, you can get or derive a lot of insights from this data. And when my mean is -2, the point is here, and then the values changes. Probability of x, come a random variable, less than or equal to my mean, it is -2, right? It is also 0.5. So in general, if my distribution is normal distribution, and if I draw a cumulative density function, distribution function, and if I say p of x less than or equal to mean is equal to 0.5, at least 50% of my points are lying less than my mean value. That is what we have learned, right? If you see the above plot, this is what the normal distribution is. You have exactly centered at mean, and 50% of the points you have on the left side, 50% of the points you have on the right side. So that is what it is saying inside a cumulative distribution function. Hopefully you learned a lot of things regarding CDF, PDF, and how we can generalize it in terms of Gaussian distribution. That's all for this video, guys. Hopefully you learned something new from this video. Let me summarize what we have learned. We have learned how to calculate PDF, and we have learned how to calculate CDF, and we have also seen what are the properties of CDF in terms of a normal or Gaussian distribution. So if you are liking what you are watching, a sub to the channel would be appreciated, and click that bell icon to get notified daily. We will meet in the next video. Bye bye.